Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in calculus. I hope that this will help you increase your knowledge in calculus, especially functions. If you want to anticipate the solution, then you may do so by pausing the video. Is it true that f of quantity g plus h is equal to f of g plus f of h? So let us verify that this statement is false. So let f of x be 3x minus 1 and g of x is x squared and h of x is sine of x. So that g plus h is equal to x squared plus sine x. And f of g plus h is equal to 3 times x squared plus sine x minus 1, quantity minus 1. So that would be 3x squared plus 3 sine x minus 1. While f of g is equal to 3 times x squared minus 1 and f of h is 3 times sine x minus 1. So f of g plus f of h is equal to 3x squared minus 1 plus 3 sine x minus 1. And f of g plus f of h is 3x squared plus 3 sine x minus 2, which is not equal to f of g plus h, which is 3x squared plus 3 sine x minus 1. So that's why we conclude that this statement is false. So f of quantity g plus h is not equal to f of g plus f of h. So that statement is false. Then determine whether the statement is true or false. If it is true, explain why. If it is false, explain why, or give an example that disproves the statement. So if f of s is equal to f of t, then s equals t. Of course, this must be true because the only way they are equal is for s to be equal to t. For instance, s is x squared. Then f of x squared should be equal to, because we have the same function here, f of t, which should also be x squared. Or else, if it is just x, they are not equal. So therefore, this statement is true. We have more exercises. So again, this statement is true. If f is a function, then f of 3x is 3 times f of x. This is false. And let's disprove this statement by considering an example. So let f of x be x squared plus 1. So f of 3x is 3x quantity squared plus 1. So that would be 9x squared plus 1. While 3 times f of x is 3 times quantity x squared plus 1, which is only 3x squared plus 3. So that is not equal to f of 3x, which is 9x squared plus 1. So that proves that this statement is false. If x, part C, if x is less than x sub 2 and f is a decreasing function, then f of x1 is greater than f of x sub 2. This is true by having the illustration here with a function that is decreasing as shown. So this is a decreasing function where x1 is less than x2, but f of x1 is higher, f of x2 is lower. So that's why f of x1 is greater than f of x2. So that's why this is true. A vertical line intersects the graph of a function at most once. So this is true. This is a function. And if we draw a vertical line, it intercepts the graph of the function in at most one point. If f and g are functions, then f of g equals g of f. By experience, this is false. Let's consider an example. Let f of x be x squared plus 1 and g of x be x minus 1. So f of g would be quantity x minus 1 squared plus 1. And if we expand that, x squared minus 2x plus 1 plus 1, so that would be x squared minus 2x plus 2. Whereas g of f is x squared plus 1 minus 1. So x squared plus 1 minus 1, which is just x squared. So they are not equal. That proves the statement that this is false. F. If f is 1 to 1, for every input, there's a corresponding one output, just like the graph represented there. Then the inverse of f is equal to 1 over f of x. This is false because, as an example, if f of x is sine x, then the inverse of sine x is just inverse sine of x. Then if it is 1 over sine x, that's not, of course, equal to inverse sine of x because that's cosecant x. 1 over sine x is cosecant x, and it is not inverse sine of x. So that's it. Then g, if 0 is less than a less than b, then ln of a is less than ln of b. So that is true. For instance, if a is 1, b is 2, ln of 1 is 0, and ln of 2 is 0.693, approximately 0 is less than ln of 1 is 0, and it is less than ln of 2, which is 0.693. So that statement is true. If x is greater than 0, then quantity ln of x to the 6 is 6 ln x. This is false because this is only true if the left side is ln of x to the 6. It is x that is raised to 6, not the entire ln function is raised to 6. ln of x to the 6 is ln to the 6 of x. That's the same, and it's different. So from algebra, ln of x to the 6 can be written as 6 ln of x. Remember, ln of x to the r is r ln of x. So that's why the only way this statement is true is when only x is raised to 6, not the entire ln function is raised to 6. So that's why it's false. Then finally, if x is greater than 0 and a is greater than 1, then ln of x over ln a equals ln of x over a. That statement is false because ln of x over a is ln of x minus ln of a by definition. So ln of x over ln a is equal to log of x over log of a, log to any base of x over log to any base of a. So let's say b base b. So that's the equivalent. Then that's why example ln of 1 over ln of 2 is 0 because ln of 1 is 0, ln of 2 is 0.693, so 0 over 0.693 is 0. Whereas ln of 1 over 2 is ln of 1 half, and it is negative 0.693. So that's why they are not equal. Another proof is ln of x over a is ln of x minus ln of a. So example, x is 1, A is 2, so ln of 1, 0 minus ln of 2, which is 0.693. That's why it is negative 0.693. So that's it for this video. I hope that you learned something, even if the discussion is not so advanced.